When you take statistics classes, one of the first things you learn is the median. And what is the median? That's what I'm going to explain today.
Teach me.
Let's say there's like 100 people in my workplace. I want to know how many people my age potentially are working with me. Let's say I do a survey. One person's age, let's say, is 20. Maybe we have two 21-year-olds, a few 23-year-olds, maybe a 22-year-old, a few 30-year-olds, and then we got like that one 40-year-old finally is getting his or her act together.
I'm the dude.
We have these numbers here. What's the average age? Average, as in what's a number here that would best summarize what we're dealing with? A lot of people think average could mean your arithmetic mean. In 5th grade, they taught you add up all the numbers, so 20 plus 21 plus 22 plus 23 plus 23 plus 22 plus 30 plus 30 plus 40, and then divide by the number of numbers there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Add up all the numbers and then divide by 9. Get the arithmetic mean. So my average would be 25.5. If you look at the data here, and you look at this average, I don't think this exactly represents the core group here. I'd like to think the core group is actually more in the lower 20s than here.
We have sort of a problem here.
Probably in middle school, when you take algebra, you're taught what the median is. So what is the median? I'm gonna rearrange this from low to high. To find the median, you literally find the middle number. 1, 2, 3, 4. 1, 2, 3, 4. And your median is this. 23 is much closer to the core group. If I'm working with these people and someone asks me, hey, what's the average age of the people you work with? 25 is not correct. 23 more represents, it's closer. See, there's a few people who are a little older, but 23 better represents this group of youngsters. There's a discrepancy between these two. Why is the arithmetic mean different than the median?
Why?
The arithmetic mean is best used when the data is Bayesian or Gaussian or normal.
What?
In other words, it's perfectly distributed.
What?
A distribution that's perfectly normal is like this.
What?
There's equal numbers of things below and above the mean.
Okay.
The mean perfectly would represent this set of numbers. But in this case, it's not the same values above and below the middle value. This number, if anything, is kind of what you call an outlier. It's just so far apart from the rest of the group, it pulls this number higher. So one of the things in statistics they teach you, the mean is subject to being influenced by how skewed the data is. For example, in this case, there are some numbers all the way up here, so the data is not normal. It's skewed. It will pull the mean somewhere here. This will become the mean. You add up all the values and then you divide by the number of values. A few numbers that are very high, the higher they are, the more they're gonna pull the mean this way. So the mean becomes less and less representative. People who are rich in America. Think of this as like how much wealth people have. And this is the number of people who have that much money. You know, there are some super duper rich people out here. Someone from, let's say, China or someone from Sweden says, what's the average wealth in America? Because there's people like Bill Gates here, their immense wealth is gonna pull the average way probably somewhere over here. Arithmetic mean does not represent actual average wealth. In cases of skew, the middle number will always be a better representation.
Please explain.
It's not affected by how big the value is. It's only affected by how many values. So if you pull a middle number, it's going to be somewhere here. The median is going to be somewhere here. In this case, the median is going to be somewhere here. This is better representative, more of the majority of the population. And some of you might ask, so what is this line? Number that appears the most. This is called the mode. In this case, we have 22, and then we have 23, and we have 30. But let's say 3 21-year-olds, then the mode would be 21. Have you ever heard the term bimodal?
Like any bimodal distribution.
Bimodal distribution.
What bimodal means is that there are two modes. In this example, it's not just bimodal, it's trimodal, right? There's 3 modes.
I mean, what is the point?
If you want to analyze numbers, you have to be very careful. The way you break down the numbers and the way you represent whatever you're trying to do, whether a majority or a distribution, you have to do it correctly, and you have to account for how much the numbers skew in a direction or not. In the future, I can teach you guys, okay, I have a median. That's just one number. How do I then get the distribution? You know, I want to know more than what the middle number is. I want to know, what is the middle 50%? That's something that would tell me more what this data means. If I can figure out, okay, this is what the middle number is, and then what the middle 50%, where does that land? So that's what I can talk about next time.
I want some more.
If you like this stuff, I'll talk about it more on this channel. Thank you guys so much for watching.